So I think now we are live on air. So welcome everyone. Good morning, good afternoon, or good evening, wherever you are. Great to see many people joining the first tutorial on causality in medical image computing. So this is really exciting. We weren't quite sure where this will be leading to when, like, I guess 6 months ago, we decided to put in a proposal and say we should bring in some causality to MICCAI. So it's my great pleasure that this is now happening. I hope you enjoyed the conference so far. What is quite interesting is actually that we saw that throughout the conference, in keynotes, in sessions, in many papers that were presented, we believe that the challenges that were discussed that the field is currently facing are actually challenges that we should or may want to consider from a causal perspective. And we really believe causality can help us there. So let me start with just a few introductory slides. So I hope you can all see my screen now. I see some people nodding. So this is a joint effort here from myself, Christine, Daniel, Nick, and Kayan, who will join us later as well. Trying to motivate a little bit why we thought it might be a good idea to run such a tutorial. So I guess if you think about causality, it's really an instrumental way of thinking in domains like epidemiology, for instance, or even general data science. Whenever you try to gain a better understanding of diseases and the cause and effect relationship of disease and pathology, we are actually really interested in the causal relationships. We want to understand how things happen, what are the mechanisms of disease, and why do certain people get sick and others don't. Causal reasoning is key to establish links between risk factors, exposures, biomarkers, treatment effects, interventions, and outcomes. And we will, especially in the first session, see some fundamental background and introduction to some of those frameworks that we can use for causal reasoning in this context. The interesting thing is, I think, or what I find really exciting about causality is that it helps and also requires us to clearly communicate what our underlying assumptions are. And especially if we talk about machine learning applied to medical image computing, we are making assumptions all the time when we build predictive models and statistical models, but we might not always be very clear about what those assumptions are. And causality really can help us with this, to be more transparent about our assumptions. Now, what's interesting is that if you look at MICCAI and more general medical image computing, medical image analysis work so far, there isn't really a lot of work that considers causality explicitly. So I tried a little exercise yesterday and tried to search for the string causal in the entire MICCAI 2020 proceedings, and there were only 5 papers out of 500, more than 500, that actually had the string causal somewhere in the main text. That doesn't mean those papers were actually on causal reasoning. I think none of them were, but these papers did mention in some aspect a causal or relationship between their data or their models. So that's quite striking, I think, and hopefully next year, MICCAI 2021, this will have changed. So if you think about also what's happening in the clinical domain, now with all the efforts of bringing in predictive models and AI to do the clinical diagnosis and other tasks, there's a lot of discussion and debate among the clinical people how they should look at this like new technology. How should they look at these machine learning based predictive models? And there's a lot of discussion around whether they need other ways of reporting, or other ways of more clearly making transparent what's behind these sometimes maybe what's considered a black box algorithm. There's just the other day, I guess a few weeks ago, there were these new guidelines being published, extensions of the traditional spirit and consort guidelines for clinical trial reporting and clinical trial protocols. And they now have explicit extensions for AI. And they ask about inclusion, exclusion criteria need to be discussed more clearly. They ask about acquisition differences, protocols, selection, sample selection for your training data, and how we handle noisy and missing data. So all these questions are actually very, very relevant, I think, for all of us. And you have seen throughout MICCAI, people are now clearly aware that we are facing a lot of challenges regarding robustness, reliability, availability of data, and generally the sufficiency is what we use for the day for training a predictive model actually sufficient? Are there any unknown confounding factors, for instance? And all these challenges, and we will discuss this throughout this tutorial, can actually be looked at from a causal perspective, and causal reasoning can help us to shed new light on these challenges and help us, for instance, with transparent reporting and also scrutiny of our work. So there are a few book recommendations here if you're entirely new to the field of causality. So those might be some of the books you want to consider for the holiday season. Clearly, if you do talk about causality, you cannot get around Julia Pearl's work, who has been one of the godfathers in bringing causality to.
Okay, we seem to have lost Ben. So that was basically the end of the introduction. So I guess we can take over now. I'm going to share my screen then to play back. We'll start with Kayan's talk on probabilistic models. Let me just share my.
Sorry about that. I think I'm back.
All right.
So this was unexpected, but this was the first slight glitch. I lost my Wi-Fi connection. So I'm maybe Daniel or Nick can tell me where I stopped. Where did I get lost?
You were saying that Julia Pearl is one of the godfathers on introducing causality to machine learning.
You shouldn't talk about gods, I guess, online. So that's maybe the problem here. So let me quickly get my slides back. Sorry about that. So yeah, we had the book recommendations. And now I wanted to talk about the schedule for today. So the first session is about introduction to causality. The way we will do it is the first two talks by Kayan and Christian will be played back. Fingers crossed the Wi-Fi will hold this time. So there are two ways you can watch these videos. You can either just lean back and watch this webinar. We will play them back, or you can go on the website and play them back yourself. They are available there. If you have already watched them, you can also take a break and come back in an hour when we do the live Q&A with respect to those two talks. We will then move to causality and medical imaging, and at the end we have a session which is very exciting with a keynote. One of the students of Julia Pearl, actually, a former PhD student, Elias Barenbaum, is giving a keynote, and then at the end we will have an open discussion, a roundtable. And we are very fortunate and delighted that Suchi Saria also will join us, the keynote speaker from Monday, to discuss pitfalls in machine learning. So this should be really an exciting session, and we'll make it open. People can ask questions, unmute themselves. It will be in a separate session, but we will come to that later. Okay, so let me get started with the introduction to causality. So I will now share these videos with you. And fingers crossed it will all go through. Otherwise, just go on the website and you can directly watch them there.